Welcome. Tonight we drift together toward one of the deepest and most beautiful mysteries the universe holds: dark matter, the unseen mass that shapes the galaxies and the great cosmic web, present everywhere yet never quite glimpsed. There is nothing to do and nothing to hold. Let the wondering be light and let it carry you toward sleep. We will move without hurry through real science and honest wonder, returning again and again to what is calm and true. Each fact is a small distant light offered only to ease your mind toward rest. You do not need to follow every thought. Let the words settle over you the way starlight settles over a dark and silent sky. Some things are well measured and certain, some are still being studied, and all of them are safe to fall asleep inside. Tonight's journey reaches into the hidden architecture of the cosmos, how galaxies spin faster than their visible stars can explain, how unseen mass bends starlight into glowing rings, and how a vast invisible scaffolding holds the whole bright universe in place. So settle in. Let your breath slow and your shoulders ease. Far out in the deep and tranquil dark, galaxies are turning slowly within their unseen halos, and we will rest right here beneath that quiet immensity tonight. Dark matter can seem like such a strange and distant idea, a thing no eye has ever seen, and yet the story folded inside it is enormous, reaching from the spin of a single galaxy to the shape of the entire cosmos. For as long as there have been galaxies, this unseen mass has been there among them, silent and invisible, holding them together and weaving the great structure of the universe in the deep cosmic dark. Tonight we will not rush through that story. We will linger in it, the way stillness lingers over a field of distant stars on a calm and cloudless night, soft and unhurried and kind. There is nothing here to trouble you. The world of dark matter is vast, yes, but it is also deeply peaceful, a place of slow-turning galaxies, faint glowing light, and steady, unhurried wonder. So let us begin softly, holding this great invisible marvel in our minds, and let its quiet immensity become the lullaby that eases you down into sleep. Here is the first quiet truth of dark matter. It is not empty space, nor a kind of darkness, nor any shadow at all, but something stranger and more wonderful, a form of matter, real mass, that simply cannot be seen. It is called dark, not because it is black, but because it gives off no light of its own, and casts back none either, staying perfectly invisible to every eye and every telescope we have. It is matter all the same, with weight and gravity pulling on the things around it, just as the ordinary matter of stars and planets does, yet hidden from sight as if it were not there. So when we speak of dark matter, we mean genuine mass spread through the universe, mass we cannot see but can surely feel by the pull it exerts on all that we can. It is a humbling thought to settle into, that the cosmos is filled with a real substance, vast and heavy and everywhere, and yet so quiet to the eye that we know it only by its gravity. Let us rest a while on the deepest reason dark matter stays hidden, for it neither sends out light, nor soaks light up, nor reflects it back, remaining utterly dark in every color we can see. Everything we usually see, the stars and the glowing clouds of gas, we see because it touches light, giving it off or catching it, or throwing it back to our eyes across the dark. Dark matter does none of these things. Light passes by it as if it were not there, untouched and unbent by it directly, so that no telescope tuned to any color can ever catch its glow. This is why it stayed unknown for so long, an unseen presence among the bright stars, betraying itself in no light at all, hidden in plain sight throughout the whole of the sky. So dark matter is the great quiet of the cosmos, mass without glow, present everywhere yet shining nowhere, knowable only by the gentle and constant pull of its gravity. If dark matter gives off no light, you may wonder how we know it is there at all, and the answer is the one thread that ties this whole story together. We feel it by its gravity. Gravity is the gentle pull that every bit of mass exerts on every other, and dark matter, having mass, pulls just the same, tugging on the stars and the galaxies in ways we can carefully measure. So although we cannot see the dark matter itself, we can see how the visible things move under its quiet influence, drawn and held and shaped by an unseen mass among them. It is a little like sensing a breeze, not by seeing the air, but by watching the leaves stir, for we read the presence of dark matter in the motions it lends to the things we can see. So the whole science of dark matter rests on this single calm idea, that mass pulls, and that by watching the pulling we can trace an invisible substance we will never directly behold. It is worth resting on just how much dark matter there is, for it is not some rare trace scattered thinly through space, but a great share of all the matter the universe contains. By careful reckoning, dark matter makes up about 27 parts in 100 of the whole universe, while the ordinary matter of stars and planets and all we can see is only about 5. So there's roughly 5 to 6 times as much dark matter as ordinary matter, the unseen vastly outweighing the seen, the bright stars a thin sparkle upon a deep invisible sea. Everything we have ever looked at, every star and world and glowing cloud, is only a small fraction of the matter that is truly there, the rest of it hidden and dark. It is a quieting thought to hold that the glowing cosmos we admire is the lesser part, a faint bright trace upon a much greater unseen mass spread through the silent dark. To set dark matter in its place, it helps to picture the whole universe shared among 3 quiet portions, each with its own share of all that is, and dark matter the great middle of them. The ordinary matter we can see, all the stars and gas and worlds, is only about 5 parts in 100, a small and shining sliver of everything the cosmos holds. Dark matter is about 27 parts, the unseen mass that pulls and shapes, far greater than the visible, the invisible scaffolding within which the bright things gather. And the largest portion of all, about 68 parts, is dark energy, a wholly different thing, not mass at all, but an effect that drives the universe to spread ever wider, of which we speak only to keep it apart. So the cosmos is mostly hidden from us, a thin, bright trace of ordinary matter set within great shares of dark matter and dark energy, 2 unseen things we must never confuse for one another. It is gentle and important to hold 2 great mysteries apart tonight, for dark matter and dark energy share a word but are utterly different things, and we will keep them clearly separate. Dark matter is mass, real substance, and its gravity pulls things together, drawing the galaxies into clusters and holding their stars from flying away into the dark. Dark energy is no mass at all, but a strange pushing effect that fills space itself, working to spread the universe wider and wider, driving things apart rather than drawing them in. So one pulls and one pushes, one is mass and one is not. One builds the great structures and one stretches the spaces between them, and they are never to be mistaken for each other. Tonight our whole concern is the gentle gathering pull of dark matter, the unseen mass that binds the cosmos, and we leave the spreading push of dark energy aside as its own separate story. The first quiet hint that something unseen was there came not from a single star but from a great swarm of galaxies moving together far out in the deep cosmic dark. A careful astronomer, studying a distant cluster of galaxies long ago, found that the galaxies within it were rushing about far faster than the visible matter alone could ever explain. By all that could be seen, the cluster did not have nearly enough mass to hold those swift galaxies together, and yet held together it was as though some unseen mass were binding it. So he reasoned that the cluster must contain a great deal of matter that gave off no light, a hidden mass whose gravity kept the racing galaxies from flying apart into the void. It was the first whisper of dark matter, glimpsed in the two swift motions of galaxies in a far cluster, an unseen mass inferred from the simple fact that the cluster did not fall apart. Let us pause and simply drift for a moment. No new facts now, only the deep cosmic hush, a soft glowing field of distant galaxies, a gentle quiet settling over the calm mind. Breathe in slowly and picture a single galaxy turning slowly far out in the dark, soft and luminous, drifting gently within its unseen halo through the silent void. Breathe out and let a little of that calm loosen your shoulders. There is so much gentle wonder in the deep cosmos, and a little of its peace is yours to rest in tonight. Let us tell that first discovery a little more fully, for it has a name and a place, and the place was a great gathering of galaxies known as the Coma Cluster. Working in the early 1930s, an astronomer named Fritz Zwicky measured how fast the galaxies in that cluster were moving and was startled by how swift they were. To hold such fast-moving galaxies together, the cluster needed far more mass than its visible glow suggested, and so he proposed that it held a great store of unseen matter. He gave this unseen mass a name in his own language, calling it the dark matter, the Dunkel Materie, a hidden substance whose gravity bound the swift galaxies of the cluster. So the very idea, and its quiet name, was born in the careful study of one distant cluster, an astronomer reading an invisible mass in the speed of galaxies he could see. It is a gentle thing beneath the cosmic web to feel how small we are, a single quiet life beneath a structure of galaxies spanning reaches beyond all imagining. The web of dark matter and bright galaxies is so vast that our whole world is less than a mote within it, a tiny speck beneath the great glowing lattice of the cosmos. And yet there is no fear in this smallness, only a deep calm, the comfort of being a small, quiet part of something so vast and so gently ordered by the unseen. To feel small beneath the cosmic web is to be eased of the weight of the day, the small worries dissolving beneath a structure so immense and so calm and so far. So let your smallness be a comfort tonight, a single quiet life beneath the great web, held within the same cosmos the unseen mass has gently shaped across the ages. There is a quiet comfort in the thought that the whole great cosmos is held, gathered and bound and shaped by the steady unseen mass, never flying apart, always gently drawn. The galaxies are held within their halos, the clusters within their greater halos, the web held in its vast pattern, all cradled by the constant pull of the dark matter. So the cosmos is not a loose and scattering thing, but a held and gathered one, bound by the unseen mass into its great calm structure across the deep dark. There is a deep peace in that holding, the sense of a cosmos cradled and bound, the bright galaxies kept gently in place by the quiet, unseen mass all around them. So let that comfort settle over you tonight, the thought of a held cosmos gathered and bound and cradled by the unseen, calm and ordered in the deep and tranquil dark. Picture as you drift, the galaxies strung like soft lights along the cosmic web, glowing gently at the nodes and threads of the great unseen frame across the dark. Each galaxy a soft point of light gathered with countless others into the filaments and clusters, the whole vast web glimmering faintly across the deep and silent void. Between the lights run the dark threads of unseen mass, holding them in their places, and the great dark voids open between the bright lattice strung across the calm dark. It is a peaceful image to rest the mind upon, the galaxies like quiet lights upon the web, gathered and held by the unseen, glowing softly across the immense cosmic dark. So hold that gentle picture as you settle, the soft lights of the galaxies strung along the great web, calm and far and beautiful in the deep tranquil silence of space. Imagine as you drift, a single quiet galaxy floating far out in the deep cosmic dark, its soft arms turning slowly within an unseen halo, calm and luminous and still. It glows gently against the surrounding void, a great slow wheel of stars cradled within its dark halo, turning so slowly that it seems to rest in the silent dark. There is nothing to do but watch it turn, this one quiet galaxy, its soft light spread across the dark, held gently by the unseen mass that cradles it all around. Let the eye rest on its slow calm turning, the gentle wheel of stars, the soft glow, the great unseen halo holding it steady in the deep and tranquil cosmic dark. So hold that one quiet galaxy in mind as you settle, turning slow and soft in the deep, cradled by the unseen, calm and luminous and far, easing you toward sleep. To look upon the whole cosmos with its web of galaxies and its unseen mass is to find not chaos but a vast calm structure, gathered and ordered across the deep dark. The galaxies strung along their filaments, the clusters at the nodes, the great voids between, all held in a grand and gentle pattern by the steady pull of the unseen. It is an ordered immensity, the cosmic web, vast beyond imagining, yet patterned and calm, shaped slowly and surely by the quiet, constant gravity of the dark matter. So the universe, for all its vastness, is a place of deep order and deep calm, a great structure gently gathered, the bright galaxies cradled within the unseen frame. It is a soothing thought to settle into, the cosmos as a vast calm structure, ordered and held across the deep dark, the unseen mass cradling it all in its quiet pull. At the heart of the whole story lies one gentle thing, the quiet pull of gravity, the way all mass draws all mass, and the unseen mass most of all shaping the cosmos. It is no violent force, but a gentle constant drawing, the dark matter pulling the matter together across the ages, gathering the web from the faintest early seeds. From this single gentle pull comes all the great structure, the galaxies and clusters and webs, the unseen mass shaping the cosmos through nothing but its quiet, steady gravity. So the grandest patterns in all of nature arise from the gentlest of causes, the soft, constant pull of mass, the dark matter drawing the bright cosmos into its great, calm form. It is a peaceful truth to rest upon, that so vast a structure springs from so gentle a pull, the unseen mass shaping the whole cosmos with nothing but its quiet gravity. Let us rest on the gentle partnership at the center of it all, the way the unseen mass holds the bright matter, the dark cradling the visible across the whole cosmos. The bright stars and galaxies are held within the dark halos, the visible matter gathered into the wells of the unseen, the seen forever cradled within the unseen. Without the dark, the bright might scatter and disperse. With it, the galaxies hold their forms and the cosmos keeps its structure, the unseen quietly holding the seen. So the visible and the invisible are partners across the cosmos, the bright matter shining within the dark mass that holds it, neither apart from the other in the great web. It is a gentle thought to hold, the unseen forever cradling the bright, the dark matter holding the galaxies in place, the seen and the unseen turning together in the deep. There is a soft beauty in the faint glow of the most distant galaxies, their light grown dim across the immense reaches of space, faint sparks at the edge of sight. These far galaxies glow only faintly to us, their light long traveling across the deep dark, and yet each is a great wheel of stars cradled within its own unseen halo. So even the faintest spark in the deepest field is a galaxy held by dark matter, its dim glow the visible heart of a far greater unseen mass spread into the dark. It is a lovely thought to rest upon these faint, distant galaxies, their soft glow reaching us across the immensity, each one cradled by the unseen mass we cannot see. So hold that gentle image as you settle, the faint, far galaxies glowing softly in the deep, each held within its dark halo, calm and distant in the tranquil cosmic. Imagine as you drift a single glowing filament of the cosmic web, a faint luminous thread of galaxies and gas stretching across the deep dark between the clusters. Along its length glimmer the soft lights of galaxies, strung like beads upon the unseen thread of dark matter, the bright tracing the dark across the immense void. The filament reaches across reaches of space too vast to imagine, a quiet glowing strand in the dark, held together by the unseen mass that drew it long ago. There is nothing to do but drift along it, this one soft filament, its gentle lights glimmering across the dark, the unseen thread holding them in their long, quiet line. So hold that single filament in mind as you settle, a soft glowing thread of the web, the galaxies strung gently along it, calm and far in the deep, tranquil dark. Dark matter is older than any star we can see, present in the cosmos from its earliest age, gathering in the dark long before the first light ever shone. It was there in the young dark universe weaving the framework of structure, while the cosmos was still too young for any star to have kindled into light. So when we trace the unseen mass, we trace something truly ancient, a presence as old as the cosmos itself, at work in the dark before the dawn of the first stars. There is a deep calm in that antiquity, the sense of a thing far older than all the visible light, the dark matter gathering quietly through the long dark age before the stars. So dark matter connects us to the very youth of the cosmos, the unseen mass that shaped the dark before the light, enduring still as the quiet frame of the bright universe. That first hint of dark matter, glimpsed in the swift galaxies of a distant cluster, was a remarkable insight, and yet for a long while it lay quietly set aside, not much pursued. It was a strange and unsettling idea that most of a cluster's mass should be unseen, and many were slow to take it up, leaving the clue resting in the scientific record. For decades, the notion lingered at the edges of astronomy, a curious anomaly noted but not yet understood, waiting for further evidence to draw it into the light. Sometimes a true idea must wait for its time, and so it was here, the first hint of dark matter held in gentle reserve until other measurements would come to confirm it. So the clue slept for a while in the books, a quiet seed of one of the greatest mysteries in all of science, waiting quietly for the studies that would awaken it again. There is a soft thread of number running through the story of dark matter, in the shares it takes of the cosmos, in the speeds it lends the stars, in the mass it spreads through space. The small share of ordinary matter, the larger share of the unseen mass, the way the rotation curves run flat, all follow quiet and careful regularities measured across the sky. These are not cold rules, but the gentle constancies of the cosmos, the numbers the dark matter quietly keeps, the same near a galaxy as in a distant cluster, steady everywhere. There is a calm beauty in that order, the sense that even the great unseen mass moves to a quiet and constant reckoning beneath the vast and varied face of the cosmos. So the cosmos keeps a quiet arithmetic of the unseen, the shares and the speeds in the mass, a soft order beneath the dark, lovely to glimpse and soothing to rest upon. After all we have wandered through tonight, it is worth asking softly why dark matter should amaze us so, why we return to it again and again with such quiet wonder. Perhaps it is the sheer hiddenness of it, the great unseen mass filling the cosmos, sure as gravity yet never seen, a secret held openly across the whole of the sky. Perhaps it is the scale of it, the unseen shaping the largest structures in all of nature, the gentle pull of the dark weaving the grand web of the bright universe. Whatever the reason, dark matter has drawn our wonder ever since its first faint hint, and draws it still, a great mystery resting calm and unsolved beneath the deep dark sky. So it is no wonder we have come to it tonight, seeking calm in its vast quiet, and finding in the science and the silence a soft and lasting peace. Dark matter does not stand apart, but lives woven deep within the whole of the cosmos, bound to the galaxies and the clusters, the cosmic web and the oldest light. It cradles the galaxies, binds the clusters, weaves the web, and shaped the faint patterns of the oldest light, part of the whole great fabric of the universe. And the cosmos in turn would not be the cosmos we know without the unseen mass, for the galaxies and the web depend upon it, the bright structure built upon the dark. So dark matter and the cosmos hold each other, each part of the other, the unseen mass woven through the whole of the universe's vast and quiet structure. It is a soothing thought to rest upon this deep belonging, the dark matter nested within the cosmos, like a quiet, unseen heart at the center of the great web. Looking back across all we have spoken of, it is striking how much the careful study of dark matter has taught us about the cosmos, even while its substance stays unknown. It has shown us that an unseen mass fills the universe, that galaxies spin within dark halos, that light bends around the dark, that the cosmic web is woven by the unseen. It has revealed the shares of the cosmos, the strength of many separate clues, the colliding clusters and the oldest light, and the great open question of what it truly is. And it has done so gently through long, careful watching and measuring and searching, drawing the secrets of the unseen mass little by little out of the dark and into understanding. So we owe a quiet debt to that devoted study for all it has shown us of the unseen mass, gathered gently across the decades of careful and loving attention to the sky. Now let the great science of dark matter grow soft and distant, all its halos and webs and clues easing into the background, like a field of stars glimpsed from far away. There is nothing left for you to learn tonight, no curve to read, no clue to weigh. There is only this one moment, and the easy rise and fall of your own breathing. Let the whole story of the unseen mass become a soft, dark quiet at the edge of your mind, the science a faint hum, the galaxies a gentle glow, all of it calm and far and fading. You are not the searcher now, but the quiet mind at rest, the wondering done, the cosmos grown gentle, the thoughts settling soft as starlight toward their own deep rest. So let your thoughts settle like the slow turning of a distant galaxy, gentle and far, easing quietly into the warm and tranquil dark. Picture, as you settle deeper, the deep cosmos spread calm and vast above you, the galaxies glowing soft along the web, the unseen mass cradling it all in its quiet pull. There is no hurry here, no task, no thought to hold. There is only the slow turning of the galaxies, the soft glow of the web, the deep calm settling over everything. The galaxies turn slow and silent within their dark halos. The web glows faintly across the immense dark, all of it held gently, all of it deeply at peace. It is a deep and lovely peace, the peace of the deep cosmos, the universe gathered and held in calm, the unseen mass cradling the bright across the tranquil dark. So let that peace be yours tonight, the calm of the deep cosmos, the soft glow of the web, the slow turning of the galaxies easing you down toward the gentle dark of sleep. One more gentle rest before we near the end. Let every fact and wonder grow distant and small, like a field of galaxies seen from far away, calm and faint and soft in the deep dark. You have wandered through the whole quiet world of dark matter tonight, the halos in the web, the bending light and the deep cosmos, and now there is nowhere left to go but rest. Let the whole soft cosmos settle into a single quiet feeling of peace. The gentle dark deepens around you, and slowly, slowly it lets you go to sleep. We have come a long way tonight, from a single hint in a distant cluster, through the whole quiet science of dark matter, the flat rotation curves and the bending of light, the colliding clusters and the great cosmic web. We found again and again the same gentle truth that an unseen mass fills the cosmos, sure by its gravity yet unknown in its substance, holding the bright universe in its quiet pull. There is nothing left to do now but rest. The cosmos is at rest too, the galaxies turning slow within their dark halos, the web glowing faint and calm across the deep dark. So let the whole quiet cosmos become a lullaby, the galaxies and the web and the unseen mass all softening into the calm that carries you gently toward sleep. Let go and drift. The galaxies will keep turning slow and silent through the night to come, and tonight the quiet science of the unseen and the deep peace of the cosmos have eased you with great care all the way down toward rest. Our journey is ending now here in the soft, deep hush of the cosmos, the galaxies turning slow within their dark halos, the gentle day folding softly toward its close. Let the facts and the wonders fade away like galaxies dimming slow across the deep dark, growing fainter and softer, until only a calm and gentle quiet remains around you. You carry within you now a whole quiet cosmos, the unseen mass and the great web, the science and the silence, resting softly now in the gentle dark. Breathe slowly now, and let each breath carry you a little deeper toward sleep, while far out in the quiet dark, the galaxies go on turning soft and silent through the night. Sleep well. The galaxies will keep turning gently through the night to come, and the soft, deep calm of the cosmos will hold you all the way until morning. Good night. To meet the second great clue to dark matter, we must look not at clusters but at single galaxies, and at the gentle way the stars within them circle round and round. A spiral galaxy is a great slow wheel of stars, all of them orbiting the bright center, drawn round by gravity as they drift through the deep dark in their long quiet circles. The stars near the center and the stars far out at the edge all move together in this turning, each held in its orbit by the pull of the mass within its circle. By watching how fast the stars move at different distances from the center, astronomers can read the hidden mass of the galaxy, for the speed of an orbit tells of the mass that holds it. So the slow spin of a galaxy is a kind of message, the motions of its stars carrying word of the mass that draws them round, a message that holds a quiet surprise. Here is the surprise hidden in the spin of galaxies, a gentle puzzle that pointed straight toward unseen mass. The stars far out at a galaxy's edge move much faster than they should. If a galaxy held only the matter we can see, its stars would move ever more slowly the farther out they lay, much as the outer planets circle the sun more slowly than the near ones. Yet in galaxy after galaxy, the outer stars do not slow down at all. They keep racing round nearly as fast as the inner stars, holding their swift pace far out into the dark. By all that the visible mass could do, those swift outer stars should long ago have flown away into the void, and yet round they go, held by some unseen and greater pull. So the two swift outer stars whisper of a hidden mass spread far beyond the bright disk, an unseen halo whose gravity keeps the racing stars from scattering into the deep. This great clue, the two swift outer stars, was measured with care by an astronomer named Vera Rubin, working with her colleague Kent Ford in the 1970s. She studied the light of many spiral galaxies, reading how fast the stars moved at each distance from the center, drawing what astronomers called the rotation curves of the galaxies. Again and again she found the same thing, that the outer stars moved nearly as fast as the inner ones, the curves staying flat far out where the speeds ought to have fallen away. This pointed clearly to a vast unseen mass surrounding each galaxy, a great halo of dark matter reaching far beyond the visible stars, holding the swift outer stars in their orbits. So through her careful and steady work, the case for dark matter grew strong and hard to deny, the flat rotation curves of galaxy after galaxy revealing an unseen mass spread wide. Let us rest a moment on the flat rotation curve itself, for it is one of the clearest fingerprints of dark matter, a simple shape that tells of a great unseen presence. Were a galaxy made only of its visible stars, the graph of orbital speed against distance would rise and then fall away toward the edge, the outer stars trailing off slow. Instead, the curve climbs and then runs nearly level, flat and steady out into the dim edges, the outer stars holding their speed where they should be fading and slow. That flatness is the gentle signature of a dark halo, an unseen mass that grows with distance just enough to keep the outer stars moving swiftly round and round. So a single curve, flat where it ought to droop, became a quiet emblem of the whole mystery, the plain shape that revealed an invisible mass wrapped around the galaxies. From the flat rotation curves, we learn that each galaxy sits not alone, but within a great unseen cloud of dark matter, a halo far larger than the bright disk of stars. This dark halo is shaped something like a vast soft sphere, reaching far out beyond where the visible stars give way to dark, holding the whole galaxy in its quiet gravity. The bright spiral we see is only the small luminous heart of a much larger thing, the glowing center of a great invisible halo of mass spread wide into the dark. So every galaxy we admire is wrapped in an unseen cloak of dark matter, a halo whose gravity gathered the gas into stars long ago and holds the galaxy together still. It is a lovely thought to settle into, that the glowing wheel of a galaxy floats within a far greater sphere of unseen mass, the visible cradled within the invisible. Without their dark halos, the galaxies as we know them could hardly hold together, for the swift motions within them would tend to scatter their stars away into the void. The unseen mass of the halo provides the extra gravity needed to bind the galaxy, gathering its stars and gas into the slow-turning wheel rather than letting them disperse. So dark matter is a kind of quiet keeper of the galaxies, the unseen hand that holds each one together, its gravity the binding that keeps the bright wheel from coming undone. In this way, the visible and the invisible are partners, the bright stars circling within the dark halo, held in their long, calm orbits by the mass they cannot see. It is a gentle dependence, then, the galaxy resting within its dark halo, the seen and the unseen turning together through the deep and tranquil dark. We come now to one of the most beautiful ways dark matter reveals itself, through the gentle bending of light, for mass can curve the path of a ray of light passing nearby. Light travels in straight lines through empty space, yet near a great mass its path is gently bent, the mass curving the very space the light moves through, so the ray is turned aside. This bending of light by mass is a settled truth of nature, measured many times, and it gives astronomers a wonderful tool, for the more mass there is, the more the light is bent. So by watching how the light of distant galaxies is bent as it passes a great mass, we can weigh that mass, even the part of it that gives off no light at all. It is a quiet marvel that the unseen can be measured by the curving of light, the dark matter betraying its presence not by glowing but by gently bending the starlight that passes by. When a great mass bends the light of things behind it, it acts like a vast lens in the sky, and astronomers call this gentle effect gravitational lensing, a natural cosmic glass. A massive galaxy or cluster, sitting between us and some far brighter thing, will bend and gather the distant light, magnifying it and reshaping it as a glass lens would. Through this cosmic lensing, the faint light of very distant galaxies is brightened and warped, letting us see farther and read the mass of the lens that bends the light. Because dark matter has mass, it lenses light too, and so the warping of distant light reveals the unseen mass directly, mapping the dark by the way it curves the bright. So the universe provides its own great lenses, masses that bend and gather distant light, and through them we glimpse both the far galaxies and the dark matter that does the bending. When the alignment is just right, gravitational lensing can draw a perfect ring of light in the sky, a glowing circle called an Einstein ring, one of the loveliest sights in all of astronomy. If a distant galaxy sits directly behind a great mass, its light is bent equally all around, smeared into a complete luminous ring encircling the unseen mass at the center. Such a ring is a clear and beautiful sign of a great mass, much of it dark, lying between us and the far galaxy, bending its light into that glowing circle in the void. By measuring the size and shape of the ring, astronomers can weigh the mass that made it, reading the hidden dark matter in the gentle curve of the warped starlight. So the Einstein ring is dark matter made visible in a sense, not by its own glow, but by the ring of distant light it bends around itself, a quiet halo drawn in warped stars. More often than perfect rings, gravitational lensing draws graceful arcs of light around the great clusters of galaxies, curving streaks where distant galaxies have been bent and stretched. A massive cluster, brimming with dark matter, bends the light of the galaxies far behind it, smearing their images into long, thin arcs that curve around the cluster's center. These glowing arcs trace the unseen mass of the cluster, the way they curve and bunch, revealing where the dark matter lies thickest within the great gathering of galaxies. By studying the pattern of the arcs, astronomers can draw a map of the cluster's hidden mass, charting the invisible dark matter by the shapes it carves in distant light. So the curving arcs around a cluster are like fine handwriting, the unseen mass writing its presence in the bent light of far galaxies, legible to those who learn to read it. Through gravitational lensing, astronomers have done a remarkable thing, drawing maps of where dark matter lies, charting the invisible mass across great reaches of the sky. By measuring how the light of countless faint galaxies is gently bent and stretched, they can work backward to the mass that did the bending, even where no light shines at all. In this way, the dark matter, though it gives off nothing to see, can be mapped like a hidden landscape, its hills and valleys of mass traced in the subtle warping of distant light. These maps reveal that the dark matter is not scattered evenly, but gathered into great clumps and threads, clinging about the galaxies and clusters in a vast, unseen pattern. So lensing turns the invisible into the mappable, letting us chart the dark matter across the sky, drawing the shape of the unseen from the gentle bending of the seen. Rest here a while in an imagined stillness, a soft, dark sky strewn with faint galaxies, the deep cosmos spread calm and vast around you, far from any care or task. You need not picture anything precisely, only feel the gentle quiet settling around you, the galaxies glowing soft and far, the great dark calm and tranquil and deep. Let your breathing slow to match that stillness. There is nowhere you need to be, nothing you need to hold, only this deep cosmic quiet to rest within. There's one place in the sky that gave perhaps the clearest evidence of all that dark matter is truly real, a great collision of clusters known as the Bullet Cluster. It is the wreck of two galaxy clusters that crashed through one another long ago, a vast, slow collision far out in the deep dark, still spread across the sky from that great meeting. In this collision, astronomers found the unseen mass and the visible matter pulled apart from each other, separated by the crash in a way that spoke plainly of dark matter. It became a kind of crucial test, a place where the idea of dark matter could be checked against the alternatives, and where the unseen mass revealed itself with rare clarity. So the Bullet Cluster holds a special place in this story, a great cosmic collision that, when carefully read, showed the dark matter standing apart from the matter we can see. Let us rest on what the Bullet Cluster showed, for it is a quiet wonder of cosmic detective work, reading two kinds of matter parting ways in a great slow collision. When the two clusters crashed through one another, the hot glowing gas of each, The ordinary visible matter struck and slowed and bunched up in the middle, dragged by the collision. Yet the mass mapped by gravitational lensing did not bunch in the middle. It passed straight through and went on ahead, separated from the gas, riding out in front on either side. So the bulk of the mass had sailed clean through the crash, while the visible gas was held back, the unseen mass and the seen matter pulled apart and left lying in different places. This parting of the mass from the gas was just what dark matter should do, passing through the collision almost untouched, and it gave a striking and direct sign that the unseen mass is real. The bullet cluster matters so much because it tests the very idea of dark matter against the leading alternative, and it does so in a clear and almost visible way. Some had wondered whether the strange motions in galaxies might be explained not by unseen mass, but by a change in the rules of gravity itself, a different and worthy idea. Yet in the bullet cluster, the mass plainly lies apart from the visible matter, out where there is little gas and few stars, which is hard to explain by changing gravity alone. For if gravity simply followed the visible matter more strongly, the mass should sit where the gas is, and not as it does out ahead of it where the dark matter sailed through. So the bullet cluster stands as a strong piece of evidence that there really is an unseen mass separate from the visible matter, and not merely a trick of altered gravity. We turn now to the grandest revelation of dark matter, its part in the very shape of the universe, for the cosmos is not a random scatter of galaxies, but a vast and patterned web. On the largest scales, the galaxies are not spread evenly, but gathered into long glowing filaments and dense clusters, with great dark empty voids between them, a cosmic web. This web of bright threads and dark hollows is the largest pattern in all of nature, a structure spanning reaches of space too vast for the mind to easily hold. And it is dark matter more than anything visible that drew this web, its unseen gravity gathering the matter of the early universe into the filaments and nodes we see today. So the great web of the cosmos is the work of the unseen, the dark matter quietly weaving the bright galaxies into their vast luminous lattice across the deep cosmic dark. Let us drift along the strands of the cosmic web, for it has a shape we can picture, all long glowing filaments meeting at bright crowded nodes across the immense dark. The filaments are vast threads of galaxies and gas, stretching across unthinkable distances, faint glowing rivers of matter strung through the deep and silent void. Where the filaments cross and meet, the matter gathers thickest into great clusters of galaxies, the bright nodes of the web, the densest knots in the cosmic lattice. And between the filaments and nodes lie the voids, immense dark hollows nearly empty of galaxies, the great quiet spaces that make up most of the volume of the cosmos. So the universe is woven like a vast and gentle net, glowing threads and bright knots strung around enormous dark voids, all of it drawn by the unseen pull of dark matter. It helps to think of dark matter as a kind of unseen scaffolding upon which the bright universe is built, a hidden framework that the glowing galaxies hang upon. Long ago, the dark matter gathered first into clumps and threads under its own gravity, and only then did the ordinary matter fall into these clumps and light up as stars. So The galaxies formed where the dark matter had already gathered, settling into its unseen wells of gravity, the bright structures growing within the dark framework laid first. The cosmic web of galaxies we see is the bright tracing of a deeper dark web, the visible matter glowing along the hidden scaffolding of dark matter that came before it. So dark matter is the quiet builder of the cosmos, the unseen frame upon which the galaxies gathered, the hidden architecture that the bright universe was raised upon. Let us follow gently how the cosmic web came to be, for it grew over vast ages from the faintest beginnings, the dark matter shaping the universe across an immense reach of time. In the young universe, the matter was spread almost smoothly, with only the slightest unevenness, tiny ripples where the matter was a touch more thick or a touch more thin. Gravity slowly worked upon these tiny differences, the slightly denser places drawing in more matter, growing denser still, while the thinner places emptied toward voids. Over the long ages, the dark matter gathered into the filaments and clumps of the web, and the ordinary matter followed, falling into the dark wells and lighting up as galaxies. So the great web grew from the faintest seeds, the gentle pull of dark matter amplifying the smallest ripples into the vast luminous lattice that fills the cosmos today. It is a quiet wonder that the galaxies themselves were born within the dark matter, gathered into its unseen wells of gravity long before their first stars ever shone. Where the dark matter clumped most thickly, its gravity drew in the ordinary gas, pulling it together and squeezing it until at last the gas could kindle into stars. So each galaxy began as gas falling into a clump of dark matter, the unseen mass, the cradle, the gathering place where the bright stars first came to be. Without the dark matter's early gathering, the gas might never have drawn together fast enough to form the galaxies, and the cosmos might have stayed dim and thin and bare. So the galaxies owe their very birth to the unseen mass, formed within the dark halos that gathered first, the bright stars kindled in the quiet wells of dark matter. Let us linger in a wide and tranquil dark, far from any care, only the soft glow of distant galaxies drifting calm and silent across the immense and gentle void. There is nothing to learn here and nothing to do, only the gentle glow of the deep cosmos, the galaxies turning slow and far in the great tranquil dark. Settle into that same soft stillness. Let it be a place with no demands, where you, like the slow galaxies, may simply drift gently and rest in the deep quiet. To test the idea that dark matter built the cosmic web, scientists have done a remarkable thing, growing whole model universes inside great computers and watching the web form. They begin with the smooth young universe, and its faint ripples set the gravity of dark matter to work, and let the model run forward across the long ages of cosmic time. As the simulation unfolds, the dark matter gathers under its own gravity, drawing itself into filaments and clumps, weaving the very same web we see in the real sky. That these models, built only on the gravity of dark matter, grow a web so like the real one is a strong and quiet confirmation that dark matter truly shapes the cosmos. So in the glowing screens of great machines, whole universes are grown from dark matter's pull, and they bloom into the same cosmic web that fills the deep, real dark. Among these model universes, one of the most famous is called the Millennium Simulation, a vast computation that grew a great patch of cosmos from dark matter's gravity alone. It followed an enormous number of pieces of dark matter, letting each pull on all the others, and watched as they gathered over cosmic time into a sprawling web of filaments and halos. The web that grew within it looked strikingly like the real cosmos, the same long threads and dense clusters and dark voids, born from nothing but the pull of dark matter. Such simulations let scientists compare the dark matter universe in the machine with the real galaxies in the sky, and the close match strengthens the whole quiet idea. So in this great computation and others like it, the cosmic web is grown again from first principles, and it blooms each time into the same familiar lattice we find overhead. There is a deep, quiet satisfaction when the model universes grown from dark matter match the real sky, the simulated web echoing the true one across the great reaches of space. The filaments in the machine fall where the filaments fall in the heavens, the clusters where the clusters are, the voids where the voids lie dark, a likeness too close to be chance. This matching is a kind of gentle proof, for if dark matter were not there, or were quite different, the model webs would not look like the real one as faithfully as they do. So the agreement between the simulated and the real is one of the strongest pillars holding up the idea of dark matter, the unseen mass needed to grow the web we see. It is a soothing harmony to rest upon, the cosmos in the machine and the cosmos in the sky agreeing so closely, both woven by the same quiet, unseen pull. There is another great clue to dark matter written not in galaxies but in a faint glow that fills the whole sky, the oldest light in the universe left from its earliest days. This soft glow comes from a time when the young universe first grew clear enough for light to travel freely, a light that has been drifting across space ever since, dimmed and cooled. It reaches us now as a faint, even glow from every direction, a gentle background to the whole sky, the relic radiance of the cosmos in its infancy long ago. Within this ancient glow lie tiny patterns, faint patches a little warmer or cooler, the impressions of the slight unevenness in the matter of the very early universe. So this oldest light is a kind of quiet photograph of the young cosmos, holding within its faint patterns a record of how the matter, dark and ordinary alike, was first arranged. The faint patterns in that oldest light hold a remarkable message, for their exact shapes and sizes can only be explained if a great deal of dark matter was present in the young cosmos. The slight warm and cool patches are the marks of gentle ripples in the early matter, sound like waves that rang through the young universe, their patterns set by the matter within. When scientists read this pattern carefully, they find it fits only if much of the matter was dark, mass that pulled but did not interact with the light, shaping the ripples just so. Ordinary matter alone could not have made the pattern we see. The dark matter was needed, its quiet gravity tuning the ancient ripples to the very shapes the oldest light records. So the faint glow from the beginning is another firm witness to dark matter, its delicate pattern bearing the fingerprint of the unseen mass that filled the universe from its youth. It is worth pausing to feel how the case for dark matter rests not on a single clue but on a whole gentle web of evidence, many separate signs all pointing the same way. The swift galaxies in clusters, the flat rotation curves, the bending of light, the colliding clusters, the cosmic web, the oldest light, each on its own suggests an unseen mass. And these clues come from quite different parts of the sky and quite different kinds of measurement, yet they agree, all calling for the same great share of dark matter. When many independent signs all point to the same answer, the answer grows strong and trustworthy, and so it is with dark matter supported from many quiet directions at once. So the unseen mass is no single guess but a conclusion woven from many threads, a web of evidence as wide as the cosmic web itself, all leading gently to the same place. Here is the great honest heart of the whole story, the quiet truth we must hold gently. We know that dark matter is there, and yet we do not know what it actually is. We can weigh it by its gravity, map it by the bending of light, watch it shape the cosmic web, and still its very substance, the stuff it is made of, remains unknown. It is one thing to know that an unseen mass is present, and quite another to know its nature. And on the second question, the cosmos has not yet given up its answer. So dark matter sits among the deepest unsolved mysteries in all of physics, a presence we are sure of, and a substance we cannot name, known by its effects and not its essence. There is a gentle wonder in that honest not knowing, a great question still open beneath the calm sky, the universe keeping one of its largest secrets quietly to itself. One thing we can say with care is what dark matter is not, and the first is that it does not seem to be made of the ordinary matter that builds the stars and worlds and us. Ordinary matter is made of the familiar small particles that form atoms, the stuff of all we can see and touch, and dark matter appears to be something other than this. For if dark matter were simply ordinary matter that had stayed dim, the careful tallies of the early universe and its oldest light would not come out the way they do. So most scientists hold that dark matter is some new kind of matter, not the atoms we know, a substance outside the familiar family of particles, strange and yet to be found. It is a humbling thought to settle into, that the greater part of the matter in the cosmos may be made of something wholly unlike the matter we have always known. Before turning to stranger ideas, scientists asked a gentle and reasonable question. Might the dark matter be ordinary things that simply give off too little light to see, hidden in the dark? Perhaps it could be faint failed stars, or lone drifting worlds, or dim dead remnants, great numbers of ordinary dark objects scattered through the halos of the galaxies. Such objects were sought by watching for the brief brightening that happens when one drifts in front of a distant star, gently lensing its light for a little while. But the searches found far too few of them to account for all the unseen mass, and other measures ruled out ordinary matter as the answer, leaving the dim object idea largely set aside. So the gentle guess that dark matter is just faint ordinary things has mostly fallen away, and the search has turned toward stranger and newer kinds of matter instead. If dark matter is not ordinary matter, then perhaps it is made of some new kind of tiny particle, a sort of matter not yet found, filling the cosmos unseen. The universe in this gentle picture would be awash with countless such particles, drifting through the galaxies and through everything, felt only by their faint gathered gravity. These particles would have mass to give them gravity, yet would scarcely touch ordinary matter or light at all, which is why they have stayed so perfectly hidden from us. So much of the search for dark matter is a search for a new particle, a hunt for a kind of matter we have guessed at, but never caught, woven invisibly through all of space. It is a quiet and remarkable idea that the great unseen mass might be a swarm of unknown particles passing through us even now, silent and gentle and unfelt. Among the candidates for the new particle, one has long been a favorite, a kind of heavy, faintly interacting particle that scientists call, with a gentle name, the WIMP. The name stands for a weakly interacting massive particle, meaning a particle with real mass that touches ordinary matter only very rarely and very weakly, almost not at all. Such a particle would drift through the galaxies in great numbers, its gravity gathering as dark matter, while it slipped through stars and worlds and us almost without notice. The idea drew much interest because such particles arise gently in some theories of physics and might have been made in just the right amount in the early universe. Yet it must be said plainly that the WIMP remains only a candidate, a promising guess not yet confirmed, for no such particle has been caught despite long and careful searching. There is another gentle candidate for dark matter, quite different from the heavy WIMP, a very light and faint particle that scientists call the axion. The axion was first imagined to solve a separate puzzle in physics altogether, and only later was it noticed that, if it exists, it might also make a fine dark matter. It would be an extremely light particle present in vast numbers, so faint and so weakly touching ordinary matter that it too would drift unseen through all of space. Searches for the axion look for its very rare and subtle conversion into light within strong fields, a delicate hunt for a whisper of a particle that may or may not be there. So the axion stands beside the WIMP as another possible answer, another candidate not yet found, a light and quiet particle that might be the unseen mass or might not. Beyond the WIMP and the axion lie still other gentle guesses at what dark matter might be, among them a quiet cousin of a known particle called the sterile neutrino. The ordinary neutrino is a tiny, faint particle that already drifts through everything, and the sterile neutrino would be a shyer relative, touching ordinary matter even less. Such a particle, if it exists, might drift through the cosmos as dark matter, its gravity gathering with the rest, hidden even more deeply than its already elusive cousin. There are other candidates too, born of various theories, each a careful guess at the unseen mass, none yet confirmed, all waiting upon evidence that has not yet come. So the field of guesses is wide and gentle. Many possible particles proposed, each a candidate and no more, the true nature of dark matter still resting beyond our reach. It is gentle and important to hold these ideas lightly, calling them candidates and not answers, for not one of them has been confirmed, and the truth may yet be none of them. A candidate is a careful guess that fits what we know and might be true, but a guess is not a finding, and dark matter's real nature has not been pinned down to any one of them. The WIMP, the axion, the sterile neutrino, and the rest are possibilities under study, each tested and sought, each still standing only as a maybe in the great open question. So we speak of them with care, as candidates worth pursuing, never as established fact, keeping faith with the honest truth that the substance of dark matter remains unknown. It is a calming honesty to rest within, this clear holding of guess apart from knowledge, the candidates many, and the answer still gently, genuinely open beneath the sky. To catch a dark matter particle, should one drift by, scientists have built great detectors and placed them deep beneath the ground, far below the surface in quiet darkness. They go so deep to hide from the rain of other particles that falls from the sky and from space, letting the thick rock above shield the detector from the noise of the world. In that deep stillness, the detectors wait with great patience for the rarest of events, the faint nudge of a dark matter particle striking an atom within them as it passes. Such a strike would be vanishingly rare and vanishingly small, a tiny flicker amid the silence, which is why the detectors must be so still, so cold, and so deeply shielded. So far beneath the surface, in caverns and old mines, these quiet instruments keep their long watch, waiting for a single gentle touch from the unseen mass that fills the sky. Pause now and imagine yourself held in a gentle cosmic calm, surrounded by the soft glow of distant galaxies, the deep dark settling vast and tranquil around you. There is nothing to fear in that soft cosmic quiet, only comfort, only the gentle glow of the galaxies and the deep calm of a cosmos held gently in its unseen pull. Let the quiet wrap around you. It asks nothing of you. Breathe slowly in that deep cosmic hush and let its gentle calm hold you, easy and still and safe. These deep detectors have gentle names and great care behind them, vast tanks and chambers built to sense the faintest possible touch of a passing dark matter particle. Some hold great volumes of cold liquid, watched by sensitive eyes that would catch the tiny flash and the small charge stirred up if a dark particle ever struck an atom within. They are built with extraordinary cleanliness and quiet, shielded from every stray source of noise so that a single rare true event would not be lost amid false ones. Year after year, these instruments grow larger and more sensitive, reaching gently for ever fainter touches, narrowing the places where the dark matter particle might hide. So the search beneath the ground goes on with patience-free devotion, great detectors waiting in the deep dark for the whisper of a particle that has not yet come to call. For all the deep detectors and the long, careful watching, one quiet truth must be told plainly. No dark matter particle has yet been caught directly, not one confirmed touch. The instruments have waited for years in their deep stillness, and the rare true strike they seek has not come, or at least has not come in a way all can agree upon. This is not failure, but honest searching for each year of watching, even without a catch, rules out more possibilities and tells us where the particle is not to be found. So the direct hunt remains open. The detectors still waiting, the dark matter still uncaught, its substance still unconfirmed by any clear touch in any deep machine. It is a gentle reminder that the great question is truly open, the unseen mass sure by its gravity yet still slipping so far through every net we have set to catch it. There is another way scientists hunt for dark matter, not by waiting for a particle to drift in, but by trying to make one in the great machines that smash particles together. In these vast ring-shaped colliders, ordinary particles are driven to enormous energies and crash together, and from such crashes new kinds of particles can sometimes be born. If dark matter particles could be made this way, they would slip out of the detectors unseen, betraying themselves only by a missing share of energy that should have been there. So scientists watch the crashes for that telltale absence, a quiet gap where energy went missing, as though something unseen had carried it away into the dark. Yet here too, no clear sign of dark matter has been found, the great colliders adding their careful negative answer to the deep detectors, the particle still unmade and unseen. There is a third gentle way to hunt for dark matter, by looking far out into space for a faint glow that some candidates might leave if they ever met and quietly destroyed one another. In some theories, two dark matter particles meeting might cancel and turn into ordinary light or particles, leaving a faint signal where the dark matter gathers most thickly. So astronomers look toward the dense hearts of galaxies and clusters, where dark matter clumps thickest, watching for an unexpected glow that might be the sign of such meetings. This indirect search reads the sky for a whisper of light that ordinary sources cannot explain, a gentle excess that might betray the dark matter at last. Yet here as well, nothing certain has been found, no glow that all agree comes from dark matter, the indirect search joining the others in calm and honest waiting. So the great hunt for dark matter follows three gentle roads at once, each looking from a different side, all seeking the same hidden substance that fills the cosmos. One road waits deep underground for a particle to drift in and touch a detector. One tries to make the particle in the great colliders, and one watches the sky for a faint, telling glow. Each road is careful and slow, and each so far has come back without a clear catch, and yet each narrows the search, telling us a little more of where the answer is not. Together these three roads ring the mystery from all sides, closing gently inward, so that whatever dark matter turns out to be, the search is reaching steadily toward it. So the hunt goes on along its three quiet paths, deep below and high above, and in the great machines all converging slowly on a secret the universe still keeps. It is only fair and gentle to give voice to a different idea, one that asks whether the strange motions in galaxies might be explained not by unseen mass, but by changing our rules of gravity. This idea is called modified gravity, and one form of it has the gentle name MOND, which proposes that gravity behaves a little differently where its pull grows very weak. In this view, there might be no dark matter at all, and the swift outer stars of galaxies might be explained by a small change in how gravity works at the faintest of pulls. It is a thoughtful and honest alternative, taken seriously by careful scientists, for it explains the flat rotation curves of many single galaxies with a simple, gentle rule. So we hold this idea fairly beside the dark matter picture, a real and reasoned alternative, the question of which is right still gently and genuinely open in the science. Yet honesty asks us to note where the idea of modified gravity finds its hardest going, and the clearest difficulty is the great collision we met before, the bullet cluster. There the mass plainly lies apart from the visible matter, out where there is little gas or starlight, which is just what unseen dark matter would do and hard for modified gravity to match. If gravity simply followed the visible matter more strongly, the mass should sit where the gas is, and not out ahead of it, where instead the dark matter seems to have sailed through. The pattern of the oldest light and the growth of the cosmic web also fit the dark matter picture closely, and are harder for modified gravity to explain on its own. So, while modified gravity remains a worthy idea, especially for single galaxies, it struggles with the colliding clusters and the larger cosmos, where dark matter fits more gently. It is a calming thing to hold this great question open with an even hand, neither closing it too soon, nor pretending we know more than we do about the unseen mass. The weight of the evidence leans strongly toward real dark matter, an unseen substance with gravity, supported from many separate directions across the whole of the sky. Yet the worthy alternative of modified gravity is not wholly silenced, and the true nature of dark matter, even if it is real, remains genuinely unknown and unconfirmed. So the honest stance is a gentle one, holding the strong case for unseen mass alongside the open question of its substance and the smaller open question of gravity itself. It is a peaceful way to rest with a mystery, to hold it open and unhurried, letting the evidence lean where it leans, while leaving room for the answers still to come. Here is a quiet and gentle thought to settle into. If dark matter is a swarm of faint particles, then it is drifting through you even now in great and silent numbers. The galaxy's dark halo fills the space all around us, and our world moves through it, so that a steady stream of dark matter particles would be passing through everything, unfelt. They would slip through your body and through the solid earth alike, scarcely ever touching a single atom, gentle and unnoticed as they pass on their way through the dark. It is a strange and calming idea that an unseen substance streams through us all the time, harmless and quiet, the greater matter of the cosmos passing gently through the lesser. So as you lie still tonight, you may picture that faint silent stream drifting through you, the dark matter of the galaxy passing through, harmless and unfelt on its long quiet way. It is worth resting on how gentle dark matter's touch upon us truly is, for though it fills the galaxy, it does nothing to disturb the quiet of our everyday lives. It does not push or pull on us in any way we can feel, does not warm us or cool us, does not touch our days at all save through its grand and distant shaping of the cosmos. Its work is on the scale of galaxies and the cosmic web, vast and slow and far, leaving the small calm world of a single night wholly undisturbed and at peace. So there is nothing in dark matter to trouble you, only a great quiet presence far above the scale of any worry, holding the galaxies gently while you rest. It is a soothing thought to hold that the greatest unseen substance of the cosmos asks nothing of you, leaving your quiet night untouched while it cradles the distant stars. Our own galaxy, the Milky Way, rests within a great halo of dark matter, an unseen sphere of mass far larger than the bright band of stars we see arching across the night. The luminous river of the Milky Way is only the glowing disk of stars, the small bright heart of a much greater thing, wrapped in a vast invisible halo reaching far into the dark. This dark halo holds the whole galaxy together, its gravity binding the stars and gas, drawing them round through their long, slow orbits, the seen cradled within the unseen. So when you look up at the soft band of the Milky Way, you're seeing the bright center of a galaxy held within a far greater sphere of dark matter you cannot see. It is a gentle thought to settle into that our own home galaxy floats within an unseen halo, cradled by the quiet mass that holds it and all its stars in place. Let us linger a moment within our own place in this story, for the sun and all its worlds, and we ourselves move together through the dark halo of the Milky Way. The sun circles the center of the galaxy on a long, slow orbit, and that orbit is shaped by all the mass within it, much of it the unseen dark matter of the halo. So our whole journey around the galaxy, taking a great span of time to complete, is guided in part by the unseen mass, our path traced through the dark halo as we go. We are, in this way, citizens of the dark halo carried round within it, our small bright corner of the galaxy held and steered by the great invisible mass around us. It is a quieting thought to rest upon that even our own slow voyage through the galaxy is shaped by the unseen, our home carried gently within the dark. Among the gentlest clues to dark matter are the small, dim dwarf galaxies, little gatherings of stars that orbit the great galaxies, holding within them surprising amounts of unseen mass. A dwarf galaxy may shine with only a faint scatter of stars, and yet its stars can move in ways that reveal far more mass than the visible light suggests, a dark halo around the dim. Some of these little galaxies seem to be made almost entirely of dark matter, their few stars adrift in a great unseen halo, the visible only the faintest trace of the whole. So the dwarf galaxies are like small, clear windows onto dark matter, places where the unseen mass dominates so strongly that its presence is especially plain to read. It is a lovely thought to settle into, these faint little galaxies cradled in dark halos far greater than their dim light, the unseen mass holding even the smallest of them together. Let us return to the early cosmos and rest on how dark matter helped the very first galaxies to form, gathering the gas before the stars could ever shine. In the young universe, the ordinary gas was spread thin and warm, slow to gather on its own, and might have stayed dim and scattered without some extra pull to draw it in. But the dark matter had already gathered into clumps under its own gravity, and these clumps gave the gas deep wells to fall into, hurrying it together toward the birth of stars. So the first galaxies formed within the dark clumps, the gas drawn down into the unseen wells, lit at last into stars within the cradles that dark matter had prepared. It is a gentle wonder that the bright dawn of the first galaxies was made possible by the unseen mass, the dark matter gathering first, so the light could follow. It is worth resting on a quiet question across the long ages. Why did the galaxies not simply fly apart, their swift stars scattering away into the deep cosmic dark? Left to the gravity of their visible stars alone, many galaxies would have struggled to hold together, their outer stars moving fast enough to drift slowly away over time. It is the unseen mass of the dark halo that holds them, its gravity binding the swift stars, keeping the galaxies whole and turning across the great spans of cosmic time. So the long endurance of the galaxies, their lasting shape across the ages, is a quiet gift of dark matter, the unseen mass holding what the visible alone could not. It is a soothing thought to hold, that the galaxies have kept their gentle wheeling shape for ages, cradled all the while by the unseen mass that holds them gently in place. Let us return to the great clusters of galaxies, for they are among the richest places to weigh dark matter, holding far more unseen mass than all their bright galaxies combined. Astronomers can weigh a cluster in several ways at once, by the speed of its galaxies, by the bending of light around it, and by the hot gas that glows between its galaxies. Each way of weighing points to the same answer, that the cluster holds vastly more mass than its visible matter could supply, the great bulk of it unseen dark matter. So the clusters are like great scales upon which dark matter is measured, their swift galaxies and bent light and glowing gas all telling of the unseen mass within. It is a quiet confirmation, the clusters weighing in heavy with the unseen, the dark matter revealed again in the great gatherings of galaxies far out in the dark. Wander for a moment among soft drifting galaxies in a calm, dark field, each one glowing slow and gentle, the whole deep void alive with their faint, quiet light. Picture them lightly, those soft, far galaxies, turning slow and gentle in the tranquil dark, calm and peaceful, glowing faint across the immense and silent void. And then let them fade. Return gently to your own quiet room, your own soft rest, the calm of the deep cosmos lingering with you like the peace of a still starlit night. Within the great clusters between the glowing galaxies lies a vast thin haze of hot gas, and it too has a quiet tale to tell of the unseen mass that holds it. This gas is so hot that it glows in light our eyes cannot see, spread through the whole cluster, and its heat and its staying tell of the deep gravity that keeps it bound. For the gas to be held so hot and so spread without escaping, the cluster must hold far more mass than its galaxies alone, again pointing to the unseen dark matter within. So the hot gas of the clusters is another gentle witness. its glow and its binding both speaking of a great mass beyond the visible, the dark matter holding it in place. It is a lovely layering of evidence, the galaxies and the bent light and the hot gas all agreeing, each in its own way telling of the unseen mass that fills the clusters. It is worth resting on how much dark matter a single galaxy holds, for in many galaxies the unseen mass far outweighs the bright stars and gas we can see. A typical galaxy may carry several times more dark matter than visible matter, its bright disk of stars only a small part of the total mass gathered within its dark halo. In some galaxies, the unseen mass is greater still, the visible stars a faint sparkle within a halo many times their weight, the dark dominating the whole quiet structure. So when we admire a galaxy's glowing arms, we are seeing only a fraction of its mass, the greater part of it spread unseen in the dark halo all around. It is a gentle reminder of how much lies hidden, the bright galaxy only the visible crown of a far heavier unseen mass cradling it in the deep cosmic dark. Let us picture as best we can the shape of a dark matter halo, for though we cannot see it, we can reason gently about the form the unseen mass takes around a galaxy. A halo is thought to be roughly round, a great soft sphere of dark matter, thickest near the center where the galaxy glows and thinning gradually outward into the deep dark. It has no sharp edge but fades away slowly, the dark matter growing ever thinner with distance, so the halo reaches far beyond the bright stars before it gently melts into the void. The simulations and the measurements suggest this rounded, fading form, a quiet sphere of mass denser within and thinner without, cradling the galaxy at its glowing heart. So we may picture each galaxy nested within a soft round halo of unseen mass, dense at the center and fading outward, a great quiet sphere drawn only by reason and gravity. Scientists have learned something gentle about how dark matter must move, for the way the cosmic web formed tells us that the dark matter is what they call cold, meaning slow. If the dark matter particles moved very fast, they would not gather easily into small clumps, and the cosmic web would have formed quite differently from the one we see. But the web we find, with its galaxies and small structures, fits best if the dark matter moves slowly, gathering gently into clumps both great and small across cosmic time. So the dark matter is thought to be cold and slow, drifting gently rather than racing, which lets its gravity draw it into the fine web of filaments and halos we observe. It is a quiet clue to its nature, this slowness, telling us that whatever the dark matter is, it moves gently through the cosmos, settling softly into the great web of mass. Let us rest a little longer on why the slow, cold, dark matter fits the cosmic web so well, for it is a gentle and satisfying piece of the whole quiet picture. Because it moves slowly, the cold, dark matter can clump on both small scales and large, gathering into the little halos of dwarf galaxies and the great filaments alike. This lets the structures form from the small to the large, the little clumps gathering first and then drawing together into greater ones, building the web from the bottom upward. The web that grows this way, with its range of sizes from the dwarf to the cluster, matches the real cosmos closely, a gentle confirmation of the cold and slow dark matter. So the slowness of the dark matter and the shape of the web fit hand in hand, the cold mass building gently the very lattice we find spread across the deep dark sky. Let us drift back to the universe before any star had ever shone, a young dark cosmos of thin spreading matter where the seeds of all later structure were quietly being laid. In that early time there was no light from stars, only the faint glow of the cooling cosmos and the thin spread of matter, dark and ordinary alike, drifting in the young dark. Within that darkness, the dark matter was already at work, its gravity gathering the slight unevenness, drawing the matter slowly toward the clumps that would one day hold galaxies. So before the first star kindled, the great architecture of the cosmos was already being drawn in the dark, the unseen mass shaping the framework the light would later fill. It is a calming thought to settle into, this long dark age before the stars, the cosmos quietly gathering itself under the gentle pull of the unseen, waiting for the light. After the long dark age, the first stars at last began to shine, kindling within the wells of dark matter where the gas had gathered thickest, the first light in a dark cosmos. The gas, drawn down into the dark clumps, grew dense and warm enough to ignite, and the first stars blazed into being, small bright sparks within the great unseen halos. So the first light of the cosmos shone from within the dark matter's gathering, the unseen mass having prepared the cradles in which those earliest stars came to be. From those first stars and the galaxies that grew around them, the long brightening of the cosmos began, all of it founded upon the framework the dark matter had laid. It is a gentle wonder to rest upon the first light dawning within the dark wells, the unseen mass cradling the very first stars as they kindled in the young cosmos. The unseen mass does more than hold the galaxies together. It helps shape their very forms, guiding how the bright stars settle into disks and spheres and graceful spirals. The dark halo sets the gravity within which the gas and stars arrange themselves, influencing how a galaxy spins and settles, whether into a flat disk or a rounded swell. So the kinds of galaxies we see, the spirals and the ellipticals and the small irregular ones, owe something of their shape to the dark halos that cradle and guide them. The visible forms are sculpted in part by the unseen, the bright stars settling within the quiet gravity of the dark, taking their shapes within the halos that hold them. It is a gentle thought to hold that the lovely forms of the galaxies are shaped not by the visible alone, but by the unseen mass that quietly guides them from all around. Galaxies seldom drift alone, but gather into groups and clusters, drawn together by gravity, and here too, the unseen mass plays its quiet part in the gathering. The dark matter of each galaxy's halo reaches out and pulls upon its neighbors, and the galaxies fall together into groups, bound within still larger halos of unseen mass. So a cluster of galaxies sits within a vast shared halo of dark matter, the unseen mass binding the whole great gathering as the smaller halos bound each single galaxy. The gathering of galaxies into groups and clusters is thus another work of the unseen, the dark matter drawing the bright islands together into great archipelagos of light. It is a soothing thought to rest upon. The galaxies gathered gently into their groups within the unseen mass, held together across the deep dark by the quiet pull of dark matter. On the very grandest scales, the galaxies and clusters are strung into the largest structures the universe holds, the great filaments and walls and voids of the cosmic web. These structures span reaches of space so vast that light itself takes great ages to cross them, the largest patterns in all of nature drawn by the unseen mass over cosmic time. The bright galaxies trace these structures like lights along a vast unseen frame, gathered into the filaments and clusters that the dark matter wove across the deep dark. So even the greatest patterns of the cosmos, larger than the mind can easily hold, are shaped by the gentle pull of dark matter, the unseen mass riding the largest of all forms. It is a humbling and calming thought that the very largest structures in existence are drawn by an unseen substance, the dark matter shaping the cosmos on its grandest scale. Between the bright filaments of the cosmic web lie the voids, immense dark hollows nearly empty of galaxies, the great quiet spaces that make up most of the volume of the cosmos. These voids are not truly empty, but very thin, the matter within them long ago drawn away into the surrounding filaments, leaving great dark bubbles in the web of light. The same gravity of dark matter that gathered the filaments emptied the voids, pulling the matter out of them and into the threads and clusters, deepening the dark between. So the voids are the other half of the web's pattern, the dark hollows shaped by the same unseen pull that drew the bright threads, the emptiness as much its work as the fullness. It is a peaceful image to settle into, these vast quiet voids, immense and dark and nearly still, the great calm hollows of the cosmos shaped by the gentle hand of the unseen. It is a quiet marvel that we can map the cosmic web at all, charting the great pattern of galaxies and the unseen mass across reaches of space too vast to easily imagine. By measuring the distances to great numbers of galaxies, astronomers build maps of where they lie, and the filaments and clusters and voids emerge from the scattered points. And by reading the gentle bending of light across the sky, they map the unseen mass as well, drawing the dark web that underlies the bright one, the hidden frame beneath. So through long, careful surveys, the great web is charted, both its glowing galaxies and its unseen mass, the largest structure of nature drawn out from careful measurement. It is a gentle wonder to rest upon, that the human mind can map a thing so vast, charting the cosmic web of light and dark across the immense reaches of the deep. Scientists have, with care, worked out a kind of recipe for the universe, a careful tally of its parts, and dark matter takes its place within that gentle accounting. By weaving together the oldest light, the cosmic web, the bending of light, and more, they reckon the shares of ordinary matter, and dark energy that make the whole. From this careful tally comes the familiar reckoning, the small share of ordinary matter, the larger share of dark matter, and the largest share of dark energy, each kept distinct. That so many different measurements agree on the recipe is a quiet strength, the shares coming out the same from many directions, a harmony in the accounting of the cosmos. So we hold a gentle recipe for the universe, its parts carefully weighed, dark matter, the great unseen middle portion, neither the visible nor the spreading dark energy. There is a calming constancy to dark matter, for it does not flare or fade or change its nature, but rests as a steady, unseen mass, drawing things together always in the same gentle way. Unlike the bright stars that are born and die and shine and dim, the dark matter simply is a quiet, steady presence, its gravity the same across the ages and across the sky. It asks nothing and does nothing sudden, only pulls gently and constantly, the same in the young cosmos as in the old, the same near a galaxy as in a distant cluster. So there is a deep steadiness in the unseen mass, a constancy that has shaped the cosmos slowly and surely, never hurried, never changed, only quietly gathering across time. It is a soothing thought to settle into, this great steady presence, the dark matter resting unchanged through all the ages, its quiet pull the same now as it ever was. Let us rest a while on the slow turning of the galaxies within their dark halos, for it is among the calmest of cosmic motions, a turning too slow for any eye to catch. A galaxy takes a great span of time to turn once round, its stars drifting in their long orbits, held by the unseen mass, wheeling so slowly that they seem to us quite still. Yet turn they do, ceaselessly and gently, the whole great wheel of stars circling within its dark halo, the unseen mass guiding the slow eternal turning of the bright. So a galaxy is a vast slow motion held within the unseen, its stars wheeling round across the ages, drawn always by the quiet gravity of the dark matter that cradles them. It is a peaceful image to hold as you settle, the galaxies turning slow and silent within their dark halos, a motion so gentle and so vast it feels almost like rest. It is worth resting on how long dark matter has been at its quiet work, for it has shaped the cosmos across nearly the whole span of cosmic time, from the young universe to now. From the earliest age, before any star, the unseen mass was gathering, and it has gone on gathering ever since, drawing the cosmic web together across the long ages. Through all the great spans of time, while stars were born and died, and galaxies formed and gathered, the dark matter held its steady course, weaving and binding without pause. So the story of dark matter is as long as the story of the cosmos itself, the unseen mass present and at work from the young dark age all the way down to the present sky. It is a calming thought to settle into, this vast endurance, the dark matter shaping the universe gently across nearly all of time, steady and unhurried from beginning to now. Let us picture how the galaxies came to lie along the cosmic web, for they did not form just anywhere but gathered into the threads and nodes that the dark matter had drawn. As the dark matter wove its filaments and clumps, the ordinary gas was drawn along with it, sinking into the densest places where the unseen mass had gathered thickest. There the gas grew dense enough to form galaxies, so the bright galaxies came to lie strung along the dark filaments, gathered into the nodes tracing the unseen frame in light. So the galaxies sank into the web that the dark matter made, settling into its threads and knots, the bright following the unseen, lighting up the hidden lattice from within. It is a gentle thought to hold, the galaxies drawn quietly into the dark web, their lights gathering along the unseen threads, the visible cosmos tracing the invisible frame. Strung along the cosmic web, between the bright galaxies, run faint bridges of thin gas, the slender filaments of the web made visible in their dim and quiet glow. These bridges are the thin streams of matter that gather along the dark filaments, drawn out between the clusters by the unseen mass, faint rivers of gas in the deep dark. They are hard to see, so faint and so spread, yet they trace the hidden filaments of dark matter, the gas gathering along the unseen threads that span the great voids. So the bridges of gas are the gentle visible sign of the web's filaments, the ordinary matter clinging to the dark threads, glowing dimly along the unseen frame of the cosmos. It is a quiet wonder to rest upon, these faint bridges spanning the dark between the galaxies, the gas drawn out along the unseen filaments by the steady pull of dark matter. It is striking how many different ways scientists have found to weigh the unseen mass, each one quite separate, each one reading the dark matter from a different gentle angle. They weigh it by the spin of galaxies, by the speed of galaxies in clusters, by the bending of light, by the hot gas, by the oldest light, and by the growth of the cosmic web. Each of these ways looks at a different thing, and each gives its own measure of the unseen mass, and yet the measures agree, all pointing to the same great share of dark matter. That so many independent scales should weigh in the same is a deep, quiet strength, the agreement of many separate measures lending the whole idea its sturdy, gentle weight. So the unseen mass is weighed from many sides at once, and the scales agree, the dark matter measured again and again to the same calm and steady reckoning. There is a gentle strangeness in dark matter that is worth resting on, for it is a substance no one has ever held, never touched, never caught, and yet we are sure it is there. We have weighed it and mapped it and watched it shape the cosmos, and still no sample of it sits in any laboratory, no piece of it has ever been grasped or examined directly. It is a curious place to stand, knowing a thing so surely by its effects, while never having held the thing itself, the unseen mass measured but never met face to face. So dark matter is known and unknown at once, certain in its presence and a mystery in its substance, a thing we are sure of and have never once touched. It is a calming wonder to settle into, this knowing and not knowing together, the great unseen mass, sure as gravity yet never held, present everywhere and grasped nowhere. The search for dark matter is a long and gentle one, asking great patience, for the answer has not come quickly and may not come for a long while yet, and the searchers wait. Year after year the deep detectors watch, the colliders crash, the telescopes scan the sky, and still the substance of the unseen mass stays hidden, waiting to be found. Yet there is no despair in this waiting, only steady, careful work, each year narrowing the search, each empty year telling a little more of where the answer is not. So the search goes on with a quiet endurance, the scientists holding faith that the unseen mass will in time give up its secret to the steady and the careful. It is a gentle thing to admire, this long, calm seeking, the steady hunt for a substance that fills the sky, pursued with care across the years toward an answer not yet come. It is gentle to wonder how the discovery of dark matter's true nature might one day come, for when it comes it may arrive in any of several quiet ways. Perhaps a deep detector will at last catch the faint, sure touch of a passing particle, the same signal seen again and again until all agree the unseen mass has been found. Perhaps the great colliders will make the particle, or the telescopes will catch its faint glow in the sky, the answer coming from one of the three quiet roads of the search. Or perhaps the answer will be stranger than any candidate we have guessed, some new idea not yet imagined, the cosmos surprising us with a truth we did not foresee. So the discovery, when it comes, may arrive gently or surprisingly, from below or above, or from a wholly new thought, the great question waiting still for its quiet answer. It is worth resting on what it would mean one day to learn at last what dark matter truly is, for it would be among the greatest discoveries in all of science. To name the substance of the unseen mass would be to know the greater part of the matter in the cosmos, to understand the very stuff that shapes the galaxies and the web. It would open a new chapter in our understanding of nature, revealing a kind of matter beyond the familiar, perhaps a whole new family of particles never before known. So the finding of dark matter would not close a small question, but open a great new view, a deeper knowing of what the universe is truly made of, hidden from us until then. It is a gentle thing to look forward to, this discovery still to come, the day the unseen mass is named and the cosmos a little better understood beneath the calm sky. Let us drift for a moment into the deep stillness where the dark matter detectors keep their watch, far beneath the ground in caverns of profound and settled quiet. Down in that deep dark, the great instruments wait, cold and silent, shielded by the rock above from all the noise of the world, holding themselves still for the faintest of touches. There is a deep calm in those underground halls, a hush far below the busy surface, where the only thing awaited is the rarest gentle nudge from the unseen mass of the sky. In that stillness, the detectors listen across the years, sensitive and quiet, ready to catch the single soft event that would at last reveal the dark matter's touch. It is a peaceful image to settle into, those silent instruments deep below, waiting in the calm dark for a whisper from the cosmos, steady and quiet through the long years. Behind all we know of dark matter lies the quiet work of the astronomers, long careful hours of measuring the spin of galaxies and the bending of light across the sky. It is slow and careful labor, the reading of faint light from distant galaxies, the careful tracing of rotation curves and lensing arcs, gathered night after night. From this steady work the great picture has been built, the case for dark matter assembled measurement by measurement, each careful study adding its quiet thread. So our knowing of the unseen mass rests on devotion, on the long, calm labor of those who watch the sky closely and ask gently what holds the galaxies together. It is a gentle thing to admire this quiet devotion, the astronomers reading the unseen in the motions of the seen, building our knowledge of the dark across the steady years. It is worth resting on how the idea of dark matter grew from a lonely hint into a firm and widely held understanding, gathering strength gently across the long decades. It began as a single startling clue in a distant cluster, set aside for many years, a curious anomaly that few pursued and fewer fully believed at the time. Then came the flat rotation curves, the bending of light, the colliding clusters, the cosmic web, the oldest light, each new clue adding its weight to the growing case. As the evidence gathered from many directions, the idea grew from a curiosity into a cornerstone, the unseen mass becoming a settled part of how we understand the cosmos. So the idea of dark matter has a gentle history of its own, a slow building of confidence across the decades, a lonely hint grown into a firm and quiet understanding. The unseen mass has shaped not only the birth of galaxies, but their long lives as well, holding them together and guiding their slow gatherings across the ages. Because the dark halos bind the galaxies, they endure across great spans of time, keeping their forms and their stars rather than scattering away into the deep. And because the halos draw the galaxies together, they gather into groups and clusters, their long histories of meeting and merging guided by the unseen mass around them. So the dark matter is bound up with the whole long life of the galaxies, holding them, gathering them, shaping the slow story of how the bright islands of stars endure and meet. It is a gentle thought to hold that the lives of the galaxies, their lasting and their gathering, are cradled all the while by the quiet, unseen mass that surrounds them. There is a quiet endurance to the dark halos, for they may outlast the bright phases of the galaxies they cradle, the unseen mass remaining when much else has changed. Stars are born and shine and dim, and galaxies meet and merge and reshape, yet the dark halos persist, steady frames of unseen mass enduring through the changing light. When galaxies merge, their dark halos merge too, joining into greater halos, the unseen mass gathering and growing even as the bright galaxies are remade by the meeting. So the dark halos are the lasting bones of the cosmos, enduring beneath the changing brightness, the steady unseen frames within which the galaxies live and change and gather. It is a calming thought to settle into, these enduring halos, the quiet unseen mass holding steady through all the changes of the bright lasting frames in the deep dark. It is worth resting on a quiet question: why is the cosmos lumpy at all, gathered into galaxies and clusters and webs, rather than spread out smooth and even everywhere? The young universe was very nearly smooth, with only the faintest ripples, and left to itself the ordinary matter might have stayed thin and spread, slow to gather into stars. It was the dark matter, gathering early under its gravity, that deepened the faint ripples into wells, drawing the matter together and breaking the smoothness into structure. So the lumpiness of the cosmos, all its galaxies and clusters and webs, is the work of the unseen mass, the dark matter turning a nearly smooth universe into a richly patterned one. It is a gentle wonder to hold that the structure we see, the very existence of galaxies and clusters, traces back to the early quiet gathering of the unseen dark matter. Let us rest on the faint seeds from which all cosmic structure grew, the tiny ripples in the young matter that the dark matter slowly amplified into galaxies and clusters. In the early cosmos, these ripples were exceedingly small, the matter just a touch, thicker here and thinner there, faint differences spread through the young dark. The gravity of the dark matter worked slowly upon these seeds, the thicker places drawing in more matter and growing thicker still, the thinner places emptying toward voids. Over the long ages, these tiny seeds grew into the great structures of the cosmos, the galaxies and clusters and webs all blooming from the faintest early ripples in the dark. It is a soothing thought to settle into that the vast cosmic web grew from such gentle seeds, the dark matter nurturing the faintest ripples into the grand structure we see. Dark matter has become one of the great recurring themes in the story of modern science, a deep mystery woven through the way we now speak of the cosmos and its making. From the first startling hint in a distant cluster to the great searches of today, the tale of the unseen mass has drawn the attention and the wonder of many careful minds. It stands among the famous open questions of physics, a puzzle named and pursued, woven into the textbooks and the talks and the long, careful labor of the searchers. So dark matter lives not only in the sky, but in the human story of trying to understand the sky, a great mystery carried forward by the curiosity of those who study it. It is fitting that so deep a mystery should hold so large a place in the story of science, the unseen mass drawing forth a long and gentle effort to know what it is. For as long as people have studied the heavens, they have found in them mysteries to wonder at, and dark matter is among the deepest of these, a great unseen drawn from the visible. From the first astronomers puzzling over swift galaxies to the searchers waiting in deep caverns, the unseen mass has called forth a long and devoted human wonder. There is something in the very hiddenness of dark matter that invites this wonder, the sense that the cosmos holds a great secret in plain sight, sure and yet unknown. So the study of dark matter is a story of devotion, of minds drawn again and again to a mystery they cannot yet solve, finding in it a wonder worth the long pursuit. It is a gentle inheritance, this long wonder at the unseen, passed down through all who have asked what holds the galaxies, and tonight we take our own quiet place in it. There is a particular calm in resting with a great open question, and dark matter is among the greatest, a mystery we are honored simply to be able to ask so clearly. We know enough to pose the question well, to say with confidence that an unseen mass is there, and to map it and weigh it while still not knowing what it truly is. That is a fine place for a mystery to stand, neither wholly dark nor wholly solved, well enough understood to be deeply pondered, open enough to invite continued wonder. So dark matter sits as a great open question beneath the calm sky, a puzzle clearly posed and not yet answered, a gentle invitation to keep looking and keep wondering. It is a soothing thing to hold this open question, the comfort of a mystery well asked, the unseen mass, a quiet riddle resting unanswered in the deep and tranquil dark. There is a deep honesty at the heart of the dark matter story, a willingness to say plainly both what we know and what we do not, and that honesty is itself a kind of comfort. We say that the unseen mass is there, for the evidence is strong, and in the same breath we say that we do not know its substance, holding the certain and the unknown side by side. We hold the candidates as candidates, the alternatives as alternatives, never dressing a guess as a fact, keeping faith with the true and gentle state of our knowledge. This honest holding is a quiet strength of science, the readiness to live with an open question, to know surely what is known and to leave the rest gently unresolved. So we rest tonight in that honesty, sure of the unseen mass and humble before its mystery, holding the known and the unknown together with an even and untroubled hand.